It's kind of wild when you think about it. An idea from way back in 1950, practically the Stone Age of computers, is suddenly one of the biggest, most important topics in technology today. So yeah, let's get into it. We're talking about the Turing Test. Because this is the kind of headline we're seeing right now. In 2023, the super prestigious journal Nature dropped this bombshell of a sentence. ChatGPT broke the Turing test. I mean, wow. That one line suggests that AI has finally, crossed this legendary finish line that was set for it more than 70 years ago.
But okay, that begs a pretty big question, doesn't it? We hear the phrase Turing test thrown around all the time, but what actually is this thing that AI has apparently just conquered? To really get why this is such a big deal, we've got to rewind way back.
And that takes us to the brilliant mind of Alan Turing. In his groundbreaking 1950 paper, Computing Machinery and Intelligence, he went right for the jugular with a massive question. Can machines think? But his real genius wasn't just in asking the question, it was in how he figured out a way to answer it. See, Turing knew right away that he was walking into a trap. The word think, what does that even mean? Is it about having a soul, consciousness? He realized that arguing about the definition was just a philosophical black hole you could get lost in forever. It just wasn't a useful starting point for science. So, in a move of absolute genius, he just sidestepped the whole messy debate. He said, look, let's replace that impossible question with a new one, something we can actually test. A game, something that could be described in, as he put it, relatively unambiguous words. And the test he came up with, which he originally called the imitation game, wasn't some ridiculously complex formula. It was actually based on a simple parlor game. Seriously, the kind of thing people might play at a party just for fun. Okay, so here's how it works. It's so simple, it's beautiful. You've got one person, the interrogator. They're basically texting with two other players that they can't see or hear. One of those players is a real person, and the other one is a machine. The interrogator's only job? Ask them questions, any questions at all, and try to figure out which one is the computer. And the machine passes the test if, after all that, the interrogator just can't reliably tell it apart from the human. And this is the absolute key to the whole thing. The test isn't trying to figure out if the machine is conscious or if it has feelings. It's all about performance. Can a machine act so perfectly human in a conversation that a real person just can't spot the difference? That's it. But of course, a simple idea doesn't mean a simple reaction. Oh no, this thing kicked off a massive debate that has been raging for decades. Is this game a truly genius way to measure intelligence, or is it just a clever but deeply flawed trick? And really, the arguments for and against it are pretty clear. On the one hand, its strengths are obvious, right? It's simple, it's practical, you can talk about anything, and you get a clear result. But the critics point out some huge weaknesses. They say it only tests for human-like intelligence, that it encourages machines to just be good liars, and, this is the big one, it can't tell the difference between actually thinking and just being a really, really good simulation of thinking. This leads us to the most famous takedown of the whole idea, the Chinese room argument from philosopher John Searle. So, picture this. You have a guy in a room who doesn't speak a word of Chinese. He has a giant rule book. When someone slides a piece of paper with Chinese characters under the door, he just looks up the symbols in his book, finds the corresponding symbols to write back, and slides it out. To the person outside, it looks like he's having a fluent Chinese conversation. But does he understand a single word? Nope, he's just manipulating symbols. Searle's argument was that a computer passing the Turing test is doing the exact same thing. But here's the wild part. Even with these really powerful criticisms, the core idea behind the Turing test is more alive today than ever before. It's literally jumped out of old philosophy books and landed right in your web browser, sometimes in ways you don't even realize. I mean, just look at this journey. It starts with Turing's paper in 1950. Then in 1966, you get this super early chatbot called Eliza that actually fooled some people into thinking it was a therapist. Fast forward to the 2000s, and suddenly CAPTCHAs are everywhere. And then bam, 2022, ChatGPT launches, and this 70-year-old conversation is suddenly the biggest story on the planet. And yeah, that little box you have to check that says, "I'm not a robot," that's a CAPTCHA. And get this, it stands for Completely Automated Public Turing Test to tell computers and humans apart. It's literally a reverse Turing test. Instead of a human trying to spot the machine is testing you to prove you're human. We're all taking a version of this test almost every single day. Which brings us right back to where we started with today's AI. Forget those clunky old chatbots. The stuff we're seeing now, it's leading to some mind-blowing results in actual studies. Just look at this number for a second, 73%. So what is that 73%? Well, in a recent formal Turing Test experiment, the AI model GPT 4.5 was mistaken for a human 73% of the time. But here's the part that's going to bake your noodle. That was more often than the actual human players were identified as human. Let that sink in. The AI was more convincing at being human than the actual humans were.
So, where does that leave us? For decades, the whole debate was, can a machine ever pass this test? And now it seems like they have, and they're even starting to beat us at our own game. So we're left with a much deeper, much trickier question. If an imitation becomes so perfect that it's completely indistinguishable from the real thing, does the difference even matter anymore?